So on this bell work, we got a little bit of subtraction there first and then multiplication second. So the first thing we see on this one is subtraction. And I would change that into addition with keep change. Okay, so plus plus, like this one. And when I combine these now with addition, I see that they do have opposite signs, but there's more positives here than negatives, which makes the answer a positive. Then you just take the two values, the big one, and then subtract the small one, because those 15 negatives will zero out 15 of those 15 of the positives there. So I'd make that 11 minus 5, so that borrows from the 6 there. 11 minus 5 is 6, 5 minus 1 is 4, 46, but positive 46. That'd be my final answer here. And then this next problem, 48 times 3, right? Well, I'm going to take 48 and multiply it by 3. Add, in the ones place value, 3 times 8, which is 24, carry the 2. And then 3 times 4 is 12, but adding those 2 makes that 14. So that'd be 14 tens, or 140, but adding the 4 there from the ones, 144 is done. All right, there's the objective. So the objective says I can use long division with negative and positive numbers. So take 30 seconds and copy that down, please. So division has many different ways to be shown in a problem. So this is probably the most familiar sign we have for division. Although it is possible you may have seen these as fractions, which is the fraction line itself is a division symbol. So if you can understand that, then that's good. When you type the division into the computer, it's probably going to look more like this division right here. And today we'll be looking at some bigger division numbers, and so it's possible you may need to use long division, although on Canvas when you put in the answers, you probably won't have to see something like this, okay? That is division, and then the first number in a division problem right here is called the dividend. What it's divided by is called the divisor, and then what it equals, that is the quotient, all right? So you're going to need to know all three of this vocabulary, because I'm going to be I will use it quite often. You'll hear me say dividend, you'll hear me say divisor, and then quotient as well. And it's possible on the homework, I think you use the word quotient in one of the word problems, and that way you will know that it would then be a division type problem, okay? Now, these words right here, the dividend, first of all, the dividend tells you how much of something is going to be distributed or, well, divided, but not only is it distributed, but it's distributed equally, and that's kind of an important part too. The divisor tells you how many groups you're going to be taking the dividend and distributing it into. So the divisor is like if you got $50 and you're going to divide it with 5 people, the 50 is the dividend, and the 5 people, that would be considered the divisor. The quotient is how much each of the people get, which in that case would be $10, okay? So in a fraction, by the way, the dividend is the numerator here, and the divisor is the denominator. So hopefully you're familiar with those fraction words. The top number in a fraction is a numerator, the bottom is a divisor. If you don't worry, we're going to go over that vocabulary again later. Something else you'll need to understand with long division is that it kind of switches the two. So the 12 is the dividend, and then the 2 is the divisor. It's switched, okay? All right. So when dividing, it's good for some people. It helps to ask the question: how many times will the divisor fit into the dividend? Like this one would be, how many times does 2 fit in 12? And you could, hopefully you know that it's 6, but if not, that's fine. If it doesn't fit evenly, then we end up with what we call a remainder, and that just tells you how much is left over. Okay, we'll look at some examples like that here in a moment. Now, division can be done, especially with some of the lower numbers, like 3 and 4, with what we call a fact family. And you can see on this problem that we have a division problem right here. So you got your dividend of 12, divisor of 4, it equals a quotient of 3. This is related to this multiplication problem right here. These are telling you exact same information, just in a different way. And that's one of the main points of mathematics, is that it is possible to write things differently, but without changing actual values. So these are the same. It just depends, do you want division or do you want multiplication? If you're okay with the division, you can keep it. If you'd rather see the multiplication, that'd be fine too. But what's going to happen in the future here is they're going to say, well, look, on this one, 12 divided by what is 3, and you could change it into this multiplication problem if you know that 3 times 4 is 12, then you'd say, oh, well, I know the answer there is 4, okay? There's other ways to deal with this, but this is what we kind of have to go with now since we're not using calculators especially. So this works very well with multiplication tables, like I said, and it's nice if you can memorize the multiplication table up through the 12s. Really just up through 9 is all you'd really need for division. But if you can get up to 12, then you'll be in much better shape. Now, I say you need to memorize this stuff. That's because when I say, hey, what's 56 divided by 7, we shouldn't have to worry about what that number is. We should just know, based on the multiplication table, that that would be 8. And if it takes a lot of thought, then you're going to be slowed down quite a bit, and you may not be able to keep up with the class, okay? So put this multiplication table somewhere where you can see it often and memorize it, because if you cannot memorize it, this class is going to be a hard struggle for you, especially when we're not using calculators. So again, fact families will be very, very nice for us. All right, so I'm going to use the table, which is essentially the fact families on this, to solve these problems. I'm going to start with this 49 divided by 7 right here. And the number I'm looking for in this multiplication table is the divisor, which is in this case 7. So I look at the 7. I use the row. You can use the column if you'd like, but I look at the row, okay? Then I'm looking in this row for a product of 49 because it's a multiplication table, and I see 49 right up in here, okay? So 49 is one of the multiples of 7, but what would 7 have to be multiplied to make 49? And that's where I follow this up into the column, and I see that number would there, it'd be 7. So that'd be 49 divided by 7, okay? Now, like I said, you could have changed this into a multiplication problem. You could have said, well, take your dividend and just make it equal to the divisor. Just make it a factor of 7 and multiply it by some value. Well, and again, some of you would know that 7 times 7 is 49, and then you would have been able to do that a little bit faster. So we can pretty much do the same thing with this next problem, 48 divided by 6. You could say, well, your dividend, it will equal the divisor as a factor now, so that's 6, but it's got to be multiplied by some unknown value. Okay, see how this even pretty much lines up. I mean, it does change the operation of multiplication. That's important to know. Well, can we do this on the table? Of course. And I just look at the multiples of 6 along this row. And is there a multiple of 6 that is 48? Yes, there is, right here. So I follow that up to up the column into what looks like 8. So that means 6 times 8 is 48. So that means 48 divided by 6 is also 8. So that answer is 8. These next two, I'm not gonna do the fact families with these. Hopefully that makes sense. If you need the fact family, use it. But on this next one, it's 72 divided by 8, and I can see that I'm looking for the row of 8, which is this row. Okay, so I'm looking in that row for 72 as a product. There it is. And so I'm going to follow it up all the way up to, looks like 9. So 72 divided by 8 is 9. Now, of course, it's not a requirement that you use the table, because if you have the multiplication tables memorized, you probably won't need it. But if it helps, then do it, okay? And then on this next one, it's 18 divided by 3. Well, there's the 3 right there. So I'm looking for the row of 3s right here. And do I see an 18? Yes, I do. Right here. That's a product. So I follow this up to 6. 18 divided by 3 is 6. Done. All right. Now, that's just using fact families, essentially, and the multiplication table to solve problems with division. But it's possible to use long division, and we've already seen this little symbol right here a couple slides back. It's got this, I don't know what that's called, but it's long division symbol, okay? But you'll notice that the dividend goes inside of the long division, and then the divisors here on the outside. The answer is the quotient. Yeah, and the nice thing about long division, especially since we're not using calculators, is it will break any of these problems up, usually into smaller, more manageable problems, because we'll be looking at just pretty much individual place values. If we need 2 or more, then we will. But it makes the values we'll look at smaller, so we don't have to look at entire large values. And yeah, you can still use the multiplication table to solve, but whether you need that or not, may not be necessary. If we see long or really big numbers as the divisor, we may make a multiplication table of our own, because we don't have all of those memorized, unless you do. And then when you do this division, though, you look at the divisor and say, how many times can it go on the dividend? But you always start with the values furthest to the left. So this is very different than what we see with multiplication, addition, or subtraction, where we usually start with the ones place value and work our way up. Now we're starting with the highest place value and working our way down with long division, okay? Now remember, we're taking the dividend and splitting it up into the divisor, so sometimes it won't split up evenly, but whatever's used from that distribution, whatever's left, we pretty much combine with other place values to the right, and then see if the divisor will go into those new values. And that's breaking this problem up into smaller, more manageable parts. And yeah, if we ever see that a divisor won't go into a dividend, we just say it goes into it 0 times. And so that will hold a place value for us, which is important to put zeros there, because if you don't, then it's going to give you the wrong answer, unless you know to go back later and fill those in. Let's see an example, because some of that may not have made a lot of sense, but if you remember long division, then hopefully this will help. So 3,105, again, that is our dividend. So 3,105 like this. I'm going to divide it. So there's my long division by 3, okay? Now, for this problem, I'm not really concerned about any of the values except the number furthest to the left, which is the thousands place value, but 3. So I'm really looking at this as how many times can I split 3,000 up into 3 different groups? Well, that'd be each group would get 1 right here, okay? So how many of those thousands did we use? Well, that's where we do this multiplication stuff. 1 times 3 is 3, and then we used up those 3, so we subtract this one right here, okay? Now that's a 0, but if we look at the rest of the place values, I go to the next one, it's a 1. What I do with that is I drop it and combine it with this place value I have, but it's a 0. I'm going to show it as a 0, and it's 1. So then I ask, well, how many times will 3 go into 1? But 1 is too small to split up into 3 equal groups, and so I'd say, you know what, it won't go into 1. So I put a 0 in that place value, and then I continue to move this to the left, right? So when I do that, I'd have a 0 here, and I can drop that 0 to make this now 10. All right, now that made the number bigger. Well, 3 go into 10. Yes, it will. How many times? Well, 3 times. 3 times 3 is 9. So we used up 9 of those 10. Using up means we're going to subtract that. 10 minus 9, 1. And then finally, our last value there is the 5. Let's go and drop that to make this now not just 1, but 15. Will 3 go into 15? Yes, it will. 15 is the 5th multiple of 3. So 3 times 15 there is, well, 5. 3 goes into 15 5 times. 5 times 3 is 15. And what you'll notice from this subtraction right here is that you have nothing else left. But we did use all the place values, thousands, hundreds, tens, and ones. And so you end up with a remainder of 0. But our final quotient is 1,035. So another way to look at this is if you had, let's look at this like money. Like if you had $3,105 and split it with 3 people, each person would get $1,035. That's another way to look at this. Now, we didn't see any negatives, and that's part of our objective, is that we should be able to do this not just with positives, but also negatives. So we're getting to that. But if you can't do the division, then none of that's going to make any sense anyways. You've got to be able to divide numbers no matter how big or small. So division and remainders. It is possible to divide, especially with long division, and have remainders. On that last one, we didn't. We could have taken that 3,105 and split it equally with 3 units. Okay, 3 groups. But on this one, see this example, like if you had 53 Hot Wheels and you wanted to distribute them evenly among 10 kids, they can be adults. But we can give each kid 5 Hot Wheels. But when we do that, right, each kid gets 5 Hot Wheels. 5 times 10 is 50. Problem is you got 3 left over. Now mathematically, we don't care what happens to those 3. Some of you would be like, well, I'm going to give them to whatever kid deserves or should get them, whatever. Okay, but mathematically, we don't care. We just say there's 3 left over. Whatever you do with them is up to you. Okay? And if there is a remainder, I believe the homework will have a separate box for that. So you may have 2 boxes to fill in, one for the quotient, one for the remainder. We'll see. But do expect some of these problems to have some remainders on them when we do this long division stuff. So here we go. This one will expect a remainder. I mean, it tells us there should be one. So I take my dividend, which is 8,891, and I divide it, because it's long division here, I'm using long division symbol, by the divisor 6. Dividend and divisor. Okay. Now, we should know the multiples of 6, so I'm going to proceed as though we know them. How many times does 6 go into 8? Once. 1 times 6 is 6. We used up 6 of those 8 in the thousands. And again, even at this point, or maybe even before, some of you may have chosen to just kind of ignore the rest of those place values. That's fine if you do. But 8 minus 6 is 2. So we have 2 left over in the thousands by taking the 8,000 and dividing it with 6. So I move this over, and I get an 8, right? So I'm going to drop that 8 to make this now 28. 6 will not go into 28 evenly, but that's okay. It will go into 28 4 times. 4 times 6 is 24. So that's 28 right there. We distribute it into 6 equal groups. Each group gets 4. So that used up 24 of the 28. So what do we got left? 4. Okay, so I look at the next place value of 9. Let's go and drop that 9 and make this a little bit bigger, like 49. 6 will go into 49, it almost exactly, but not quite exactly, 8 times. Okay, 8 times 6 would be 48 right there. And when I subtract this, I get 1 left over. Now that's the tens place value. I got to move this over for the ones. I do need a little bit more space. But now I say, well, 6 won't go into 1, but if I drop this other one right here, that would make that 11. Okay. Will 6 go into 11? Yes, it will. How many times? Just once. 1 times 6 is 6. When I subtract this, see, now I end up with a remainder on this one. 11 minus 6 is 5. So not only do we have a quotient, but we have a little bit remaining. But for now, we would say that this is the quotient, and then this is the remainder. You probably won't have to put the R in the homework, but do expect there to be some problems that have remainders. Some of you may be thinking, well, we can make that a decimal, right? Yes, we could, but we're not doing that yet. That'll come later. Now we'll have to divide it with larger numbers. Larger divisors specifically. So if we ever see a divisor that's bigger than 12, I like to make a table of the first 9 multiples. That's as far as we need to go, the first 9 multiples. And you can use addition to find each of those multiples. We'll show you how to do that. But this, the nice thing about making a table like this is going to give you a nice reference source. So you don't have to keep wondering to yourself, what is this times whatever the divisor is, especially since they're usually going to be pretty big numbers. So like this one right here, okay? Now, I'm going to write this out as long division. So it's 7,921. This will be divided by 89, okay? Now, I'm going to make a multiplication table here on the left, and it's just going to include, all I want is the first 9 multiples, okay? Now, the first multiple of any number is always itself. So I have this 89, that's my first multiple. I'll highlight these later to indicate which of the multiples they are. But in order to find the second multiple, I don't need to multiply by 2, I just need to add it to itself. 9 plus 9 is 18, carry the 1. 1 plus 8 is 9, plus 8 is 17. So 179, that's 178. There we go. So that's the second multiple. The third multiple, just add another 89 here. That's a 17, 1, 6, 267. Add another 89er. 7 and 9 is 16, carry the 1. 1 and 6 and 8 is 15, carry the 1. 356, what is that, my fourth multiple? Add another 89, this would be the fifth multiple. There's a 5, 1, 14, carry the 1, there we go, 445. So that's my fifth multiple. I just need to go up to 9, that's as far as I need to go. So plus another 89, this would be the sixth multiple, 14, carry the 1. 1 and 4 and 8 is 13, carry that 1. 1 and 4 is 5. 534. What's that, 6 multiples? So I only need 3 more. Plus another 89. 4 plus 9 is 13, carry the 1. 1 plus 3 plus 8 is 12, carry that 1. 623. And then add another 89. So what are we up to? 7 multiples, 2 more. 3 plus 9 is 12, carry the 1. 1 plus 2 plus 8 is 11, carry the 1. 7, 12. And then that's the 8th multiple, just 1 more. So add another 89, and we get 2 plus 9 is 11, carry the 1. 1 plus 1 plus 8 is 10. 1 plus 7 is 8. 801. Okay, so like I said, I'm going to highlight each of those so that I know which of these are the actual multiples of 89. And I know it's kind of small, but hopefully we can still see that. So 89 is the first multiple, 178 is the second, 267, 356, and the rest of them. Okay, there's all 9 of our multiples that we would ever need for 89. And again, we don't expect you to memorize those, which is why I created that table right there. So now I can start on my problem, and just like usual, we start with the place value furthest to the left. So that's the 7 in the thousands place value, but guess what? 89, 7 is too small to split up with 89 groups. So it won't go into 89. Okay, so let's move this over. How about 79? No, still too small. I mean, it's close, it's just still too small, so I got a 0 there. All right, fine. Well, let's move this over and make that 792. Will 89 go into 792? Yes, it will. And so to figure out which of these you need, 792, 801 is too big, so we got to go to the one next lowest, which is the 712. That's the 8th multiple. So I know it won't go into it evenly, but it's close. 8 times 89, just like I can see right there, is the 8th multiple, 712. See that? So I used up 712 of these. And when I subtract, this will tell me how much remains of the 792. So 2 minus 2 is 0, 9 minus 1 is 8, 7 minus 7, that zeroes out. Okay, so that takes care of those 3 place values. What if I move this over 1? All right, then I got this 1, just drop it, make that 801. Hey, look, see, that's the 9th multiple. Exactly, so 9 times 89 is 801. And we end up with nothing remaining on this one, which is good. But the final quotient here is 89. That's the main number we need on this one. So notice how I used the table. I didn't have to use all the table, but I only used these 2 values. I didn't have to think, well, how many times does 89 go into 792? Because I'd already made my table right here and made that a very easy problem to work with. And so my recommendation is if you see bigger numbers like, well, 89, or anything bigger than 12, that you just look at these values and then make your own table like that. All right, anything divided by 1, which you will see, this is the identity property for division. If you ever see a number all by itself, it's possible to write it as divided by 1. It's always there. This is called the phantom 1. It's lurking in the shadows, always watching, which makes these kind of creepy, but you can show them if you like, okay? So, but anything divided by 1, whether it's a letter or a number, is always itself. And remember, division can be shown with fractions like this, and this is kind of how we use division by 1 in the future, at least more frequently, we use it in this fraction form like this, okay? But anything divided by 1 is itself. And so if you took any number, no matter if it's positive or negative, or decimal or fraction, anything divided by 1 is going to be itself. So, I mean, yeah, we can make up our own number. I don't know, -4, I guess. Anything divided by 1 is itself. So -4 divided by 1 is still -4. How about dividing with numbers that are considered base 10? So it's just, it's being multiplied by some 10 base. What we're talking about is the zeros, really. Okay, you don't have to worry about the base 10 stuff, but it's the zeros. Like this, 3,000 divided by 500 right there. And as it turns out, what you can do in this is any numbers, any zeros furthest to the right, you can just kind of cross those out. Now, we're not crossing those out. Some people say cancel out, but what that does, these are ones right there, but they become phantom 1s. And what this does is it takes really big numbers and changes them into fairly small numbers. 30 divided by 5, yeah, we can do that one. That'd be just 6 right there, okay? So there we go. But like I said, you just take out any zeros that you want and then use your division, okay? So what about this one? Now this one's not written as a fraction. That should be okay, whether it is or not. And here's why. Because any zeros furthest to the right will, again, it's not really that they cancel each other out, just that they become phantom 1s. Now you'll notice from the dividend on this one that there's still 4 zeros here. No other zeros to really phantom 1 each other out with the 3 though. So what you could do, you could just rewrite this as 120,000. And 1, 2, 3, 4 divided by 3, like this. And it's the same problem, it's just shown in a different way. if this happens and you have a lot of zeros in the dividend like we do right here, just take those zeros and attach them to the answer. 1, 2, 3, 4. But it has to be the dividend. It can't be zeros from the divisor. That would mean something completely different. But now look what I've done. I've taken this problem and I've now changed it again into something even smaller. 12 divided by 3 is 4. And then I just tack on that 4 to my zeros that I already had. That ends up being 40,000 right there. And that's as far as I need to go on this one. All right, as promised, we have to be able to determine and work with negative values. So this slide should look pretty familiar because last time it was just multiplying, but now it's multiplying and dividing. It's the same exact rules to determine if your answers are positive or negative. And that's the first thing you're going to be doing on these problems. First thing, determine if your answer is positive or negative, and then you operate. All right? So in these next few problems, we're just going to be determining if the answer is positive or negative. But see here, if it's got the same sign, positive and positive, whether it's division or multiplication, the answer is positive. They match the same sign. Or if they're negative and a negative, your answer is going to be a positive if they match or have the same sign. If they're opposites, no matter if the order, negative, positive, positive, negative, when you're multiplying or dividing only for multiplication and division, your answer will be a negative. That's if the signs are opposites, okay? You don't need to solve these. All we got to do is determine if the answers are positives or negatives. So this first one, 78 divided by negative 3. Yeah, I can see that that has a positive and negative in this one. So they are opposite signs, making this answer a negative. Okay, fair enough. What about this next one? Well, that's a negative and a negative. Those have the same sign, so that would result in a positive. So there's my positive there. All right, now this next one, that's negative 8 and negative 289. Again, I really don't even care about the numbers, just the signs right here, negative and negative. They have the same sign, which would make this answer a positive as well. Now, some students look at this next one and they say, look, there's 2 negatives on this one. Nope, there's only 1. Let me show you how this could be rewritten. If we ever see something like this, we usually attribute the negative to the numerator, the top number. This becomes negative 72 divided by positive 9. So it's a negative and a positive, which would result in a negative answer on this one. So be very careful about these negatives right here. There's only 1 right there. And so the answer is a negative. Now this next one as well, opposite signs, negative and a positive. They're opposite signs, which would make the answer here also a negative. Now there's our process. Determine if your answer is positive or negative, then operate. Once you start operating, we're ignoring any of the positives or negatives after that. It's just pretty much treating them all as positive. Get rid of any of your negative signs is what we're saying when you start to operate, because you know your answer is positive or negative. It's the first thing we're going to do on these. Just like we did with multiplication, addition, and subtraction. It's the first thing you should do with operating with negatives. Just determine the sign of the answer first. So a problem like this one, what's the sign of this answer? Well, these are both positive. They have the same sign, which make the answer positive, and hopefully you wouldn't have to think too much about that. But what I'm going to do is I'm going to write a multiplication fact family on this one. That'd be 56, the dividend, is now the product, equals our divisor, just multiplied by whatever the answer is. That's what we're going to put into this slot, okay? So 7 times what is 56? That's 8. So that means 56 divided by 7 is 8 as well. But again, we want to focus on the answer to this one being a positive, not just an 8 on that one, because the signs were the same. What about a problem like this one? Again, the first thing we should do is determine the sign of the answer. I have a negative and a positive. They're opposite signs, which makes this answer a negative. Okay, then you just get rid of the negatives. 12 divided by 3, is that something we can do? I really hope so. How many times will 3 go into 12? 4 times. Just don't forget to tack on the negative sign as part of your answer. It's negative 4. Here's this one, negative 48 divided by 8. You guys try this one out. Take 30 seconds to try this one out. All right, here we go. Negative 48 divided by 8, no problem. First thing we want to do is figure out the sign of the answer. They are opposite signs, which makes this answer a negative. Well, then just treat it as though they were both positives. 48 divided by 8 You use the fact family on this one to make it 48 equals 8 times something. That'd be the same answer right there. So 48, 8 times what is 48? That's a 6 right there. Of course, some of you already knew that was 6. I'm just using the fact family here to kind of help some of those that it may be helping. Just don't forget to tack on the negative to the answer there. It's not just 6, it's negative 6. All right, this is a division problem. Some students even like to show the division like this. That's fine if you do, as long as you get the same answer. That's the main thing on this one. So, what is the sign of the answer? We got a negative and a positive. They're opposite signs, which makes this answer a negative. Well, then just do 35 divided by 5, which is really all this is. And how many times will 5 go into 35? It's 7 times. So we end up with a negative 7 answer. Done. All right, 144 divided by negative 9, and 144 is a little bit big, even though I know some of you could do that probably in your head, and that's great if you can. First thing still, before we get to the division, is what's the sign of the answer? And it's opposite signs on this one. One's positive, one's negative, which makes the answer a negative. Now, 144 is a little big, so I'm going to do some long division here. And again, I know not everyone needs it, but I'm going to show it. So I'd say, how many times is 9 going to 1? It doesn't, so you can put a 0 there if you like. Some people choose not to, and that's fine if you don't. So, but then you got to treat it like 14. How many times is 9 going to 14? Once. Here's a different color. Once. 1 times 9 is 9, so we used up 9 of those 14, which leaves us with 5. Drop this 4 to make that 54. How many times is 9 going to 54? 6 times. So 6 times 9 is exactly 54, and we have nothing remaining, which is kind of what we wanted. We'll just make our final answer a negative 16 is all. All right, negative 81 divided by 3. Take 30 seconds and try this one out, then we'll go over it. All right, let's go ahead and go over this one. First things first, though, what's the sign of the answer? It's a negative and a positive, which makes this answer right here a negative. Now, 81 is a little bit big for 3. I know some of you may know this by heart. That's fine if you do. I'm still going to use long division. How many times does 3 go into 81? Well, just 8 really for now is twice. 2 times 3 is 6. So when I've used up all 6 of those, 8 from the 8, which leaves me with 2. And then I'll drop the 1 in the ones place bag. Make that 21. 3 will go into 21 exactly 7 times. 7 times 3 is 21. And when I subtract that, I get a remainder of 0. Now, you'll notice that on this one, I did not use a table of multiples of 3. That's because, again, hopefully we know and have memorized all of our multiples of 3, at least the first 9. But the first 27, probably not, and that's where long division may come in a little handy right here. All right, 36 divided by negative 4. Again, we want to see the sign of the answer first. And I see that these two signs are opposites, which would make this answer a negative. That just leaves me with 36 divided by 4, which hopefully we have down as 9. Whether you use the multiplication table or multiplication fact, still 9. It's just the final answer here is negative 9. That's it. All right, so you're going to see some word problems on the homework as well, something similar to this. Now, this is all division, so we should kind of expect to see division, whether it is or not. And for those of you that struggle with writing these types down, yeah, you may have to read it several times. Like this one, write an expression that represents the quotient of 4 and 13. Now, quotient, we know, is division, right? That's the answer to a division problem. So there's our division. And what are the two numbers? The first number they give us 4, so that has to be our dividend. And the second number is 13. That must be the divisor. 14 divided by 13. 4 divided by 13. And it does have to be in this order. You cannot switch these with division. It means something very, very, very different. Now, there's a couple different ways you can write this. Sometimes you'll write it as a fraction like this, 4 divided by 13, rather. On the homework, I don't think there's either of these signs, so you're going to have to do it like this. You're going to have to type in a 4, and then for the division, you're going to use the slash button. I think it doubles as the question mark. I could be wrong. But it should look something like this instead. Now, you'll keep in mind as well, if these were negative, right, you could say, well, negative 13 and negative 13 like this, if it were. So that's hypothetical, but it could happen on the homework. That's the important thing to notice about the division on these, is division order does matter. If it were a multiplication problem like we saw in the last lesson, the order does not matter. But yeah, with division, order definitely matters. You have to keep track of the order of these. You convince your brother to do your chores. Every day he does your chores, you owe him $5. At the end of the month, you owe him $45. Write an equation to show how many days he did your chores. Now, there's actually several different ways you could write this. And you could actually use subtraction, or you could use addition. I would say you could possibly even use multiplication. But since this unit is on division, that's what I'm going to go with. Okay, so I'm looking for division here. Now you can see in the end of the month, you have the $45 that you owe him. Now it's 45, but since it's owed money, it's going to be a negative $45. Okay, and you're paying him $5 every day he does the chores. So we're going to divide that by the $5. But the $5 is also owed, so I'm going to make that a negative 2. Now you could put that in parentheses if you like. I'm not going to worry about it right now. And on the homework, I believe it will accept both with parentheses and without. So what's the sign of my answer? Well, they're both negatives, which makes my answer a positive. Okay, well then I just focus on 45 divided by 5. I think we've seen this one already. It's 9. It's just this is positive 9. On the homework, they're going to want this full expression right here, the full equation rather. And again, the division symbol is just a slash, I think, on Canvas. That's what you have to put in there. So the test for this unit is on Friday. Here's our objective. I can use long division with negative and positive numbers. So next time we do have the mastery quiz on multiplication and division. And then on Friday this week we'll have the test on this unit, which includes not just division with negatives and positives, but also addition and subtraction and also multiplication. So be prepared for that.